We talked about ANOVA last week, right? This is, a topic for the take-home exam. You're gonna have one problem in the take-home exam, specifically for ANOVA, where you need to construct a table. Remember last time we made table. It is called one-way ANOVA. Sometimes you may have couple, parameters, but in this class we are not gonna go in deep, two-way ANOVA where you um, compare, you're gonna study two parameters and how they interact with each other. So the one-way ANOVA was that you consider, for example, you have different machines and they are making, parts, and you want to see whether, different machines, are making different parts, are, the part they are producing, they are in the right variations, something like that. Or healthcare, or it can be different industry, like um, timing the for a layout. You construct, several layouts for producing a part, and you want to see, um, which one is more effective, or there is a significant variations between different, layout in the assembly line. Um, so you see, for example, these are the data from, let's say, three machines, and each one is producing, part. Each one has, each machine has its own, mean value, right? And this a bell shape for each machine. You can construct it, and then we want to see variation between them. But if you don't do, you don't isolate the variation for every machine, you just get one, standard deviation for the total, right? You make, one plot, so that doesn't tell you, whether, you know, um, there is a significant effect between the machines. So we, in this ANOVA, which is used in design of experiment a lot, you can, set up the experiment, you collect the data, and then you want to analyze it, right? So this is one way to analyze those collected data from, the design of experiment. ANOVA means analyze of variance. Sometimes we call it, ANOM, which means analyze of means. Analyze of the mean value. Okay, in the ANOVA, we have two hypotheses. One hypothesis is that, all the mean value for every machine are going to be the same. So there is no significant difference between the group, means. All machines are producing the same, parts. So this is called a null hypothesis, one way. Alternative in hypothesis is that at least one of the, let's say that last week we were talking about teaching method. It can be machine, it can be, hospital. You have several hospital, their recovery time for one disease in one hospital is 5 days, in another hospital is, 4 days. You want to see whether, the recovery time for different hospitals, there is a significant difference between them or not, right? So if there is, then, you have alternative hypothesis. You have to see, what is the cause of that, difference between teaching method, or machine or other things. We were, when we look at the standard deviation for the entire, data set, we use the total variance, right? If you get, a square root of a total variance, it's going to be a standard deviation, right? We use this equation. But we sometimes, this is going to be a little difficult, to handle. We can make it, easier by looking at this equation. I showed you, how to use This two terms, you can find this two term. What is it? Xij. Let me, because we're gonna do one no problem. So I do this board because okay. When you have Xij means every let's say this is I, this is J. We're gonna include all of them, right? One X of one. This is let's say this is 5. This is 6. X 5 6. You're gonna get summation. First, it's not simply summation of the number. You have to get take them to the power of 2, right? You can make another table, and then this x11 to the power of 2, right? And construct this for all the number, and then what's next is get the summation of all of them. Get summation of all these numbers. Xij2. Okay, so this is one. Next one is get the summation of all the numbers from here. Xij, get simply summation of all numbers, and then to the power of 2. Right? What is n? N is the total of observation. If you have total of total number 25, you put n 25. So what is this? This is the total variance. But total variance is not all we need. We need variance between groups. Between group, this is the equation, but again we use the simpler one, which is this one. Okay, xi power of 2 which one is that? Is it this one or this one? This one, right? Look, xi. Oh, this is x here to the power of 2, right? Then you repeat this one for here. Let's say x1, x2, x3. Then add them up. You have to divide by the number, the net n for that column. Every column has a specific number of observations. Sometimes, you may have 5 observations for this one, right? So the ni is going to be 5. But for, let's say, if you are looking at the hospital, in one hospital you had 5 observations, you had 5 patients. In another hospital you had 10 patients. So your observation for this one hospital B is going to be, let's say B10. So you get summation of all this one, divide by the number. This is 5. For this one will be 10. What's this? We already found it, right, from the previous one, which is this one. But there is one term, divide by n. N is the total number of data you have observation. So that gives you the between group, variance between groups. You see,
if your variance between groups is small, means your data, all the data you have from different machines are closer to each other. If variance is too large, data are isolated from each other. Next is bit in. You see, this is for bit in. This is another, and this one. What does it mean? If variance between group is too big, so your data are too far from each other. So this is an equation, but it's better to use this one. Xij, summation of all of data, and this one, right? Use this new table. Summation of all of them, xi, power of 2 divided by ni. So, I have a class activity, and in that class activity, it said assembly time using different workstation layout. Let me find that. It doesn't show here. Okay. Before we go to the class activity, let's. So once you find those information, you can use this table to find whether there is a significant difference between means or not. So you see this this table. This is called ANOVA table for one way. Okay, on one way ANOVA. It has source of variation, right? Degree of freedom for each one. Treatment also is another name of the between groups. This sometimes we call it treatment. Sometimes they call it within between different sources. Error or within. This one is within every group, and this is total. What is the degree of freedom? To represent the number of independent pieces of information. So how can we find the degree of freedom for between different teaching methods, hospital or the machines? Just no, you have the number of machines. Just subtract 1 from the number of machines. So if you have 3, so divide, subtract 1 from it, it's going to be 2. So whatever number you have, k is going to be the groups. How many groups you have, just subtract 1. And within every machine, you have to divide n minus k. What is n? Is the total number of observations. Here you have, let's say, 25, right? Then what was the number of groups? Whatever it is, 3. So you divide, you subtract k from this n. Let's say this is 3 machines, 25, observation. So that will be 22, right? Degree of freedom for within is going to be 22. And the degree of freedom, this should be for the total, and no, this. The total is going to be 9, the total number of observation minus 1. So this is the total. Okay, So now we have degree of freedom. We want to find the sum of the squares, sum of the square for the width n, and the total. Then find the mean sum of the squares. Use this equation, and these are the degree of freedom. Once you have these two information, the mean sum, you can find the f-test. F-test, you can find the f-test from table, from chart. If your f value, this is called calculated f, right? The statistic f. And then there is a critical f on the chart. You find that f from the chart, you compare them, right? If your computed f is bigger than the chart f or the critical f, that means there is a significant differences between the machines, or healthcare or other things. Okay. So how can we find these number? Once you find these components, you can go to this equation. Where is this one? This equation, you see, you need this one, right? That is going to be the same as this. Only three factors you need to find. This one, right? This and this, because this is the same as this one, right? This one is the same as this. What else? This one and this, they are the same. You just need to find these, three summations. Okay. And so once you find these numbers, these three, you take them to that chart. These are the degree of freedom. You put the number, in there. The mean sum, you can calculate it. The mean sum is just this one divided by this number. MSE is going to be this divided by this one, 21. Then once you have the mean sum, you can find that you can compute the F statistic, which is dividing this number by this. So that is going to be, let's say you don't have it here. Oh, okay. 3.5, 3.4. Let's see. Okay, 2.3. So that is my computed F value. Okay? So then I go to this chart. This chart, remember, it has an alpha. You have to mention, you have to look at the question, what alpha they, they say. If they say 0.05, then you can use this chart. Okay, because there are different type of F table based on this critical value. And then you need 2 DF, degree of freedom. Degree of freedom 1, degree of freedom 2. So degree of freedom 1 is going to be the observation. This one, right? 3. Degree of freedom 2 will be this. This number. So you find these two, then you can find the number. So this is the critical value. And my, computed one is less than this number. So that means there is no significant difference. If this was 5, that means there is significant effect between machines, different machines. So one machine is making better product, the other one. The one product that is not in the standard. Okay, so I have this class activity. The way I did it, I made all the tables, so I want you to do, use your calculator. It's assembly time. We have 4 layouts, A, B, C, D, and each one is making it has a different assembling time. So we want to see which whether there is a significant difference between this assembly line. Okay. So how we need to construct this table? Remember? So this table you have to find the degree of freedom, total number, the sum of the square, SS between, SS within, total, and then mean sum of the square, find this number, and then find this F value. Okay? So this is the first page. In the second page, you see, the timing for each layout. This is, layout 1. We have 5 observations. Okay. Layout B, we have 4. Layout 3, we have 3 observations. Layout B, we have 6 observations. So you can use this one as a work paper. You can, because remember, you need to find this component, right? What is it? It means first we have to find the summation of this number, right? Put that summation here, same thing here. Do the same thing for this column, this one, and then add them up. Put that here, but you have to make it power 2 for that value. So that is needed. This is xi to the power of 2 divided by n. So what is xi? Average of this one divided by number n. Here, how many n do we have? For this one, we have 5, right? For the first column. Second one, we have 4. So you have to repeat this process, and then get to this point. Yeah, you can, yes. Once you get all of them, then add them up. Add all of them, all these numbers together and put it here. You also need this value, right? For that value, you have to construct another table. Every number up there have to be, you get to the power 2 for all of them. You have to repeat it, summation of all of them, and then summation of these numbers goes there. So once you have these 3, you can put them here, find this, SS between, SS within, SS total. Once you have these 3, you can bring them back to this table and repeat, follow these tables. Okay? So initially, you have to go to the second page to find, these 3 numbers.